Thank you. So this is the title. We'll see what it means. On to my favorite topic. Repeat some of the things you've already heard. I identify as a systems and database architect. It's something that we've kind of forgotten. We talk about software and we talk about databases and we talk about data layers, but we don't talk about systems in general. And having a bird's eye view approach to systems design is beneficial. And this is the point of these talks. It's knowledge sharing, because it's good to spread the knowledge outside the small bubble of database administrators that frequent places like this, the PostgreSQL room at Scale. I'm very grateful to Scale for the invitation. This is my second time here. I'm actually based in Edinburgh in Scotland, so I had to take a really long flight. I have been using open source and trying to contribute back for over 25 years. I have been using Postgres exclusively for more than 16 years now. Probably need to update that slide. Closer to 18, actually. And I have written a couple of books on Postgres. This is going to press very soon from Manning, PostgreSQL mistakes and how to avoid them. It's based on observations and things that I've seen people do wrong in the field, also mistakes I've made. I've also co-written with a few other brilliant PostgreSQL people the Postgres 16 administration cookbook. And I am the author of the PG StatViz extension for Postgres for visualization and time series analysis of Postgres internal statistics. Now, on to the talk. Let's see what we're going to be talking about. We're going to see what row-level security is in Postgres, when you should use it, how it works internally, how to use it, but also what's wrong with it, and what you can do about that. We will also be talking about more things you can try with row-level security. So let's look at the motivation for this talk. This is a slide I always include, is why are you giving this talk? So I had a customer at some point that wanted the users of their application to not see each other users' data. Duh. But here's the catch. This customer was used to their application being badly coded. So they expected data leaks from one user to the other. Unfortunately, the original design of their application contained things, REST URLs, like /user/identifier/data. And by guessing, or just brute forcing, you could find another user's valid identifier and read their data. So that's bad. So let's see what row-level security is. It gives you fine-grained control over which rows in your table are visible to which users. It provides additional security beyond the table or column level privileges we're used to with SQL. And that means the grant statements, right? You can only grant permission on a table or column level. And that is not fine-grained enough if you have rows in the same table that should not be visible by everyone. So it's a type of access control list for database rows. And its main use case is it saves you application-side security filtering. In the case of the customer that I mentioned, it actually saved them from data leaks because their application didn't even care about these things at that point in time. It's all been fixed now. So when would you use row-level security? One good use case is when you have confidential data. So you would want a way to restrict access to sensitive records. For example, you might be a doctor, but you want your assistants to be able to see the appointments, but not the, let's say, the patient records. Just a random example. I don't know how these things work. Another use case is role or departmental separation. So if you have content that is only relevant to one role or function in your organization or one department. So for example, only HR needs to be able to see the rows that are relevant to HR. Multi-tenant systems is another use case where you have many customers or tenants cohabiting in the same table. And that is a very valid use case, right? Because you don't want to be creating a table for each one of your customers. I remember a use case in the past where an organization did exactly that. And they ended up with 120,000 tables named order and another 120,000 tables named invoice. So they had like 250,000 tables in their database, which drove Postgres crazy because all of these things needed to be recorded in the Postgres catalog. And then you needed to vacuum the Postgres catalog every time you added a customer or removed a customer. So anyway, let's not get sidetracked. Obviously, you wouldn't want your tenants or customers to be able to see each other's data in the same table. Again, finer-grained visibility control. If you want to grant access to specific rows versus specific tables. So let's see exactly how it works. So from the user's perspective, and we're talking about database users here, we're not talking about application users, the rows that they're not allowed to see simply don't exist for them. That is the end result of row-level security. The rows that are not visible to you are simply not visible to you. You don't even know how many rows there are that you can't see. You don't even know that they exist. So there are some key concepts around RLS. Policy is one, where you define policies or conditions for reading or modifying rows. So you may want to base access on some condition that you define elsewhere. Like, if this user is a member of HR, then they're able to see. If they are a director in HR, then they are able to read and modify rows, and so on. And also, there's a security barrier that doesn't let you bypass RLS with clever tricks like using and abusing views, because you can trick the query optimizer to leak data even when it's protected by row-level security if the security barrier is not defined in the creation of those views. So that's the other component. But how does it really work? So RLS is exactly, I said it's like an ACL, it's exactly an ACL. It's an access control list. This is what it's implemented like internally in Postgres. So internally, what happens is when you run a query that is subject to an RLS policy, you're effectively adding where conditions to the query. So you're saying select from this table where this condition that I defined applies. And the where gets applied automatically because of the policy. So you can define policies that are permissive or policies that are restrictive. So what does that mean? Permissive policies have a Boolean OR between them. So if you have a permissive policy A and a permissive policy B, because it's like an OR between the two permissive policies, right? So if policy B is satisfied, then we don't care about policy A, right? We don't have to check it. You're granted access. Restrictive is the opposite of that. It's a Boolean AND between the conditions. So if a policy C is restrictive, then it doesn't, and it's not satisfied. Policy D is satisfied because both of them need to be true, right? So if policy D turns false, then no access is granted because they're. So let's dive a little bit deeper and see how it's stored internally. We have the PG policy that you can access that has columns like policy relation ID. So that's the table to which the policy applies. PolCMD is the command for which the policy applies. So which command have you written the policy for? Have you written it for selects? Have you written it for inserts, updates, deletes, or all of the above? Do you have, oh, sorry. So the default is true for permissive policies, but you can set it to restrictive. And Pol roles is your access control list. It's basically the array of roles that the policy that you defined applies to. Pol qual is qualification. It's the using clause that you specify when you create your RLS policy. And Pol with check stores the with check clause if one exists. We'll see how that works. So really, how to use it, right? All you need to do is alter your table to enable row-level security. Besides defining the policy, that's all you need to do to enable the policy. Now, the problem with this is that, and this is generally in accordance with Postgres's security by default stance. So you would expect row-level security to have as a default deny access by default, right? So when you turn on RLS for a table, it denies everything if there's no policy defined. It means nobody can access this, right? So the thing that grants access is the policy. So how do you create a policy? Create policy on which table? Customer, for all. SQL commands, it means for all. To public, and public here is the keyword that means every role in the system. Using, and here's the using clause that we talked about, using this condition. So if this condition is satisfied and it's true, then access is granted through this policy. So what is my condition here? It's customer user equals current user. And again, we're talking about Postgres roles here. And a Postgres role, a Postgres user is a role that can log in, really, so you can use role and user interchangeably. So in this case, whoever is connected as the database user, if their username is the same as the column customer user, then they have access to the data. So it's as simple as including a role name in another column alongside. That is a very simplistic use case, but it works fine. So how does it work? Let's say you select star from customer. This internally turns into something like select star from customer, where customer user equals current user. And current user, as we said, returns whoever's logged in for the session. Okay, so we saw that it works. It's relatively easy to implement. What about the clickbait title? It does suck, yes. But RLS sucks too, and we'll see why. So the thing that's wrong with the way that RLS is implemented, but the thing is, it assumed that your application worked in a certain way that applications used to work like. So what do I mean by that? So nowadays, people generally don't have their data separated by the database user that accesses the data. So it's kind of illogical to assume that separate users of your system or your application will be connecting to the database with a separate database user. Additionally, you wouldn't want Postgres to manage your application's users. So what does that mean? It means you would have duplication. So for every application user, you would need a Postgres user as well. The problem with the roles system in Postgres is that its scope is global. So it is not restricted to a single database or a single table, right? Users can roam throughout the entire Postgres cluster or group of databases. So the scope isn't restrictive enough for if you have multiple databases. The other problem is that the role system in Postgres wasn't designed to give you application-level features. So you can't store your users' attributes or preferences, for example. So again, you would need to store those in your application. And you know, another problem with having this duplication of application user corresponding to Postgres user is the fact that you need to keep these in sync. So whenever you lose a customer or you gain a customer, you have to create or disable a role in Postgres. So that's a challenge as well. Additionally, like, I don't want to say 90% or 99%, but a lot of applications that I have seen tend to connect to the database using a single user. In many cases, it's the wrong user because they connect a super user just to read from the database. So that's another problem. But let's assume that the developers are sane and the DBAs have talked some sense into them and they're using a non-privileged user to connect to the database. But they're still using a single user. So that is useless for applying row-level security because everyone is the same user. So this makes auditing really difficult because you can't tell who changed what and who saw what in the database. And for many use cases that I've seen, changing the way the application works to switch to connecting using multiple users would require a significant rewrite. And in many cases, this isn't feasible for economic reasons, because nobody wants to rewrite an application that works, or because the application is a black box, right? In many cases, the application that your customer is using may have been provided by a third-party vendor, and they may refuse to change their code because they say, you know, we don't care about your Postgres stuff. We sell our software all over the world, and it works fine. So we also mentioned this, aligning application and database users is tedious. You inevitably will end up with a spaghetti of grant statements, because for each user that needs to be able to read data from those tables, you would only want them to read from those tables and not access the rest of the tables of your system. Again, remember that the impetus for this talk was the application was badly coded, and everyone in that organization's management feared that through SQL injection or SQL injection, however you prefer to say it, some unauthorized person would be able to trick the system into showing them tables or rows that they weren't supposed to see. We talked about synchronization. So what is really the solution to this? So one possible solution is to set variables in your session and refer to those variables in the policy. So you could create a policy, trans policy, for the table transaction for all commands, and you grant it to public, so it applies to everyone, using tenant equals current setting. So current setting returns Postgres configuration settings, but also variables that you've set in your session. So in this case, I have a setting called app.tenant. That is the identifier or name for my tenant. And I'm using the policy to match the column tenant to this value. So in this way, I don't have to connect as role tenant to the database. I can use the existing connection, but I have to set the variable app.tenant to the corresponding tenant value before I can run the query. Which works fine, because if you don't set, you don't get access to anything. So that's kind of safe. Now, why have I prefixed it with app.tenant? If you don't prefix it, it thinks it's a Postgres configuration setting, so you need a prefix to differentiate it from actual Postgres stuff. So this is your variable, and you've namespaced it into your domain called app, for example. So all you need to do is set app tenant equals megacorp, and then megacorp is able to see the rows in the table that belong to them. But what if you are feeling paranoid and you think that someone would be able to set this value anyway, right? Exploiting, I don't know, badly written code or some loophole, and they would be able to guess that megacorp with a capital M is the name of the tenant. So in that case, you would turn it into something opaque like a UUID. The identifier of the tenant, that is. So you create the policy using tenant equals current setting app tenant, but whatever string is stored inside app tenant, you cast it to a UUID. And then you match the UUID to the UUID that you've stored in the column tenant. And that way, nobody knows really what their UUID is. So, and it's really, really, really hard to guess someone else's UUID. So you would then set app.tenant to be a string that, excuse me, a string that represents this UUID value, and it works much the same way. Remember to cast it, because if you compare a string that represents a UUID with a UUID, that returns false, right? So you need to cast it to the proper type that you've actually stored in the tenant identifier column. Now, another consideration is that you may be using connection pooling. So you may not want to set app.tenant. You may want to set local app.tenant so that it's only valid within this transaction. And it doesn't, so if your connection pooler like PG Bouncer reuses the same connection for other transactions, then that would leak into other transactions if you set it, because it's a session level variable. So by setting it local, this restricts the scope to the current transaction. So after the transaction is done, it's gone. And it can't leak through the connection pooling mechanism. So, do you want us? Yes, is what I expected. Let's take it a bit further and add role-based access control to our ACL that we've created. So we explicitly define the access control list the way we just saw, but then we add role-based access control on top of that. So we differentiate between tenants and their roles. And it's really the example that I talked about before, that you have access for HR, and you have separate access for Jimmy within HR, or separate access for directors within HR, and so on. So that is based on roles. So how do you implement that? You would add an ACL column to the table. So you would alter your table transaction to add a column called ACL with the type array of UUIDs. Can you guess why? Because we want to store an array of roles that have access to this row, right? And arrays are a great Postgres extension to the standard because you can store multiple values per row in the same column. So this is ideal for this use case because we can store a list of UUIDs that represent roles that have access to this row. Of course, you set it not null, and you set, for sanity reasons, you set the default to not be an empty string, but to be an empty array of UUIDs, right? Because that helps with sanity checking and comparisons. So, seeing that we like using UUIDs for role identifiers, this is what we decided to use, an array of UUIDs to store the access control list and the row-based access control. So instead of setting the tenant, we're setting the roles that are granted access in the ACL. So you would do that as simply as this. Set app tenant roles equals string, and this is how you represent an array in string notation in Postgres. So curly brackets, UUID1, comma, UUID2, close brackets. And then you must remember to cast this into an array of UUIDs, because right now, as a session variable, it's a string. So what would the policy look like for such a thing? So you would create policy, trans-role policy on transaction again, for all to public, using. Now here's the weird syntax. It's ACL, double ampersand, current setting, app tenant roles, and we cast it to an array of UUID. what does this syntax mean? The double ampersand basically checks if the first array, our ACL, and the second array have common elements. And for us, that is sufficient, right? If you have even one role that allows you to see this row, then you are granted access to this row, right? So this is what this double ampersand operator does. It checks to see if there are elements in the second array, which is the array of UUID roles, and if it has any elements that are in the ACL. Remember to alter your table, enable row level security, otherwise the policy doesn't apply. So, what this policy does is it checks if any of the tenant roles are inside the ACL, but it also gives you role-based access control, because the roles can have attributes that define their privileges. So, like Postgres roles, they can be thought of as groups of one or more tenants. Like we said, the group HR, the group directors of HR, and so forth. And you can also define your roles to be able to grant roles to other roles, and then you have an aggregate of the privileges. So it is basically exactly how the PostgreSQL role system works. Why not copy something that works, right? Do you want to dive even deeper? How would you protect this system that you've now built that implements access control and role-based access control from your application that you don't trust? So you don't want your application to be able to go in and change the ACLs by itself, because you've decided that it is exploitable, and therefore it shouldn't know about these things. It should only be granted access to read from the database and write to the database. Because after all, it can connect to those tables and read from them. So what you need to do is you need to hide direct access to this ACL and RBAC system from your application. Why? We said that you don't trust it, or you don't trust the third party, because you're nice that way, you trust your own developers now. So let's assume that for the purposes of this example, we're using a Django-based app. So in the database, on the database side, you would create a role named Django or whatever for the platform that's going to connect to the database, right? Because we have already admitted that we were only using one user to connect to the database on behalf of the application. So you create the role Django, and then you create a table transaction. It has an ID. It has, this is a really simple example. It has an ID, an amount, created that timestamp, and it also has an ACL, right? Because we need an ACL column to implement this. And because it needs to hold a number of roles, it is an array of UUIDs. So to speed up ACL enforcement, we would need an index that supports array operations, right? Because if you have a whole lot of roles and a whole lot of rows in your table, you need some way to instantly find, or as close to instant as possible, to find how you can, which rows you can access. So you would create an index on your table transaction using GIN is a good index to use here, because GIN supports array ops. So if you use the modifier array ops on the index creation on the column ACL, then that doesn't create a full GIN index. It only creates the parts that it needs for array-based operations. And if you remember, the array-based operation that we used, double ampersand, is one of those. So this makes double ampersand, so belonging operations really quick. So again, on the database side, you would create a table called tenant role, and this is how the role system works inside Postgres. So you have a role ID, a role name, and you would want to add a role description to make it human readable, what this role entails. And this is the Postgres mirroring part. You have another table called tenant role member that records the membership of tenants to roles. So let's assume that you have tenants elsewhere in your system and they have a tenant ID. This is where you make a tenant ID correspond to a role. And this is how you can belong to multiple groups or multiple roles at the same time as a tenant. And then you create an index on tenant role member to speed up membership operations and so on. So the next step is you want to remove the ability of the database user Django to see these inner workings that we've constructed. So the brute force method is revoke all on tenant role from Django. We don't have any privileges on the table tenant role or the table tenant role member. So it doesn't exist for them. But how are they able? You want Django to be able to access the role-based system somehow. You also want to hide the ACL from the application. Because let's assume that someone abusing your application is able to select the entire row. Then they would be able to see the ACL as well, and they would be able to see which other users of the system or tenants have access to this data as well. So in some cases, you don't want that, because it might be confidential information that they're not supposed to know. So you also revoke select on transaction from Django, so you hide every column, and then you grant access back only to the columns excluding ACL. So you grant select to Django on that table, and you only grant access to ID, amount, and created at. So they can no longer perform select star, and they now have to perform select using these three columns that are available to them. Then you create the policy. So create policy trans RLS on transaction using ACL double ampersand current setting app tenant roles equals true. So if any of the tenant roles are found in the ACL, grant access. That's all that means. Remember to alter the table to enable row level security afterwards. So I said that, okay, Django should be able to manipulate the role system, but not through direct access to the tables, right? So you want this to be done in a controlled manner. So what do? You create stored functions that Django can call, that manipulate the role-based access control system, the roles, and which roles get access to which row, but not through direct manipulation of the tables, only through those functions. So you have a function called create tenant role, where you feed it a role name in text and a role description, and it returns the UUID. It goes to that table, it creates a role, returns the UUID of that role to Django. You get another function, get tenant roles, that when you give it a tenant ID, it returns an array of UUIDs, which are the roles that this tenant has. And also, you need a third function. So this is at minimum, right? So at minimum, you need these three. You need a function called set tenant roles that takes a tenant ID and a list of role UUIDs, and it sets all roles for a tenant. So that's the minimum implementation you need. There is one more thing that I've just barely touched upon, that for each table, we would require, so for each, in the case of Django, for each type, for each class, right, that corresponds to a table in the database, we would need a function that means add a role to this row, because you want to select specifically which rows you want to grant access to which roles. And correspondingly, you would want to remove role-based access from a specific row. So you need these two functions. And these two functions can belong to some sort of Django automation. For example, you can include them by overriding Django's .save function. So whoever's logged in, when Django saves something on their behalf, then it calls those functions that we just defined through overriding the save function and sets the access control appropriately, more or less automatically. Or you can use some sort of middleware that does this transparently as part of the connection layer between Django and the database. Remember, when defining these functions, we need to define them as security definer, right? Because Django doesn't have access to those tables, but you do. So you grant access through these functions to those tables by allowing security definer. And that means that they get your level of access for those functions. But these functions are written by you, so you control strictly what they do with those tables. Remember to set search path equals public, pgtemp, at the bottom of each function definition when you're using security definer. Because you don't want people to be able to create temp functions that exploit this mechanism to get access, right? You don't want people to trick these functions into executing where they shouldn't be. And that's a good point. Please namespace everything. Don't use the public schema, right? So if you have an application called app, create a schema called app, and create your functions there, create your tables in there. The public schema is more or less deprecated, and you can see that by the fact that in recent Postgres releases, you don't even get access to create objects in public anymore. So let's see what this function would look like. Sorry for the small fonts. So you would, let's say that you have an object called order, and it has a corresponding table called order in the database. So you would create a function called order ACL add, and you give it an order ID and a role ID. And then this function goes and updates, sorry, that's a mistake. It should say order instead of company there. It would update order, set ACL. It would check to see if this is already in the ACL or not, and then it would append it and so forth. So it's a really simple function, and it allows you to add access to a specific role to that order ID. It is trivial to write the inverse function that removes access for that role from that row. Now, a few catches. You need to remember that policies can add overhead to queries. So if you have a complex condition that defines the access criteria, like if this user complicated join with another table, then complicated join with a third table, right? That would slow down your queries because it would get applied for every single row of the table. Remember, we said row-based access control, right? So for every row in the table, it goes and checks this condition to see if it's satisfied, right? So that's going to be a problem if it takes long to check. So what you should do is you should keep your policies simple and very explicit. Remember that the super user can bypass all row-level security checks, so never connect your application as a super user to the database. Remember that the table owner can bypass the row-level security check unless you have specified force row-level security, right? So table owners get to bypass RLS if this is not set. Remember to set a restrictive delete policy because people assume that if you can write to a row, right, that means you can delete it as well. But no, delete operation is quite distinct from update. So you need to remember that people shouldn't be able to delete rows they can read. So let me give you an example. If you have given access for someone to see the row, that means they can delete it if there's no delete policy, even if you've defined an update policy. Right? So you wouldn't want people to delete rows they can read but not update. By setting a restrictive delete policy, that means that no matter which other conditions are satisfied, they're not able to delete. We already said make sure you reset your variables between sessions, especially if you're using PG Bouncer or some other sort of connection pooling. Remember that statement mode and PG Bouncer will not work. It's like auto commit, so everything is its own transaction, so it won't work with set or set local. So you can't use this with PG Bouncer in statement mode. Fortunately, the primary use case for PG Bouncer is transaction mode. So there's no problem there. Apart from, remember that you cannot leak these variables between transactions. So if you're using transaction mode in PG Bouncer, remember to set local. Otherwise, if you're not using connection pooling, set is enough. We briefly mentioned with security barrier when you're defining views, because you want to stop any kind of malicious function that defines itself with cost equals 0001, and therefore the planner prefers this function every time, right? You don't want this to be able to trick the query planner into selecting this function instead of something else. Meaning, if you write a function that is preferable to the query planner and your function tries to leak data, right? For example, instead of reading the rows, because it cannot select the rows, it creates a notice with the values of those columns in that row, right? So it does a raise notice and still leaks the data. Security barrier prevents that, so it doesn't let the function access the data. So you create the view. So the question was, where do we define the security barrier, right? So when you create view, you just specify with security barrier, and that prevents leaks of that type, like people playing clever tricks with raise notice, for example, that can access the values even if they can't select the values. And that's about it. Thank you for sitting through my boring talk. As a thank you, you get some QR codes that give you discounts for my book, PostgreSQL Mistake, and any other Manning product. and you also get a discount from Amazon for the other book. Thank you very much. Questions?
Yep.
Yes.
Any questions there? Sorry, if you have a question, can you lift? Okay.
So, as far as I understand, can you hear me all right?
A bit closer, please.
So, as far as I understand, you're advocating that we create functions that we then, the code that that inserts records would call those in order to manipulate the ACL, right? If I understand that correctly, right? Like those functions that you mentioned. So, since we're also setting the user roles anyway in the database, can we somehow populate them automatically into tables on insert? Is that something that's possible?
So the question was, do I advocate having functions that manipulate the ACL through the application if we can pre-populate those roles on insert, was your question. Instead of manipulating through the save, yeah, you can do that. But if your application then edits the row, it needs some way to change the ACL if that was the nature of the edit. So yes, you can predefine in Django or whatever other tool or framework you're using, you can predefine it to give specific roles to that row. The thing is, and I have done that, right? We had a record type in this database that was publicly accessible, so every user of the system would be able to read it, and that was created by default when you created a new row. So I don't know if I've answered your question.
In what kind of applications do you think this solution makes sense for? Is this something that you think is potentially a good idea for anything where we have user accounts and data that is only accessible to specific users or sets of users? Or is it more of a niche solution for cases where you really don't trust your application and or your application developers?
No, it's applicable in any case. It's good practice to have this separation. I don't know if you want to go down to the third level of implementation, role-based access control plus ACL plus hiding it from your framework. I don't know if you want to go as deep as that. But if you want role-level security, then that is the, I don't want to say modern, but it's the realistic way to approach it. Now that every application basically uses one user to connect to the database. So I don't think that it's a niche market. If you have like multi-tenancy, it absolutely makes sense to implement this. Some industries that regulate this are finance. The finance industry absolutely requires you to not even be able to leak access to those records to other people. And the same goes for medical records and so on. I don't really advocate using it in every case, but if you have these sorts of concerns, like you're really worried about the consequences of someone inappropriately seeing other people's records, then you should implement something like this.
Okay, so you think like this is a preferable solution to enforcing such things at the application level?
So you can enforce it at the application level, but only if this was a design consideration you had taken into account when you were writing the application. So retroactively, this is the way that you would fit it on top of an existing application. Again, it's a policy thing. So does your organization's policy trust the application with the database access or not really?
Thank you.
So in this example, we don't trust the Django user. We restrict its access. What's the concrete way that the Django user in like a given session and context knows a given UUID for a user? I'm imagining an application where like...
Sorry, can you repeat that?
How does the Django user know like a particular UUID to even set in the session?
It calls the function get roles. And then if it has some sort of description of the role somewhere that corresponds to a text-based description, then you can match them with the roles, with the role UUIDs in the database.
Oh, sorry, I meant like tenant IDs. How does it know like what a tenant ID is? Is there like a layer
Yes,
of locking them?
the Django code knows what a tenant ID is. It knows what a tenant is. So that is not hidden from Django. The role-based access control part in the ACL is hidden from Django. But Django understands tenant ID. Yeah, I should have made that clearer, that it's already implemented. And you may not call them tenants. You may call them users or customers or whatever.
I guess what protections are in place to stop just the Django user from enumerating all roles by calling these functions on like every single tenant if it knows what all the tenant IDs are?
So your question is, how do we stop Django from abusing these functions?
Yeah, or is there some sort of enforcement mechanism or auditing, given that we don't trust the Django user to begin with?
Yeah, stopping it, not really, but I would assume that the code wouldn't be coded badly enough that it would let you perform a brute force loop over the entire set of tenants. And again, it wouldn't expose the information that links the records to the UUIDs, right? Auditing is definitely something you should consider in high security environments. So you can implement, you can add an extension like PG Audit that records all accesses to the tables, and then at least you're covered in the legal sense that it may have happened, but you tracked it and you stopped it and you have the evidence.
So maybe a follow-up to this question. So a lot of systems today use JOTs, Java Web Tokens. So these are signed JSON that tell you the user and the audience, right? Like the kind of the roles that the user is authorized for. And if you could have Postgres check those, then you wouldn't have to trust the application. The application would need some source that signs users JSON tokens, and then the application just passes them to the database, which verifies them.
Yeah.
Did you see some way for application to set these tokens in and for Postgres to verify them when they when?
Yeah. So the question is, can you use JWTs for this thing? Can you grant access to specific JWTs, and when Postgres sees them? Right now, Postgres doesn't have a JWT. I'm looking at Magnus there. It's not in the plans to implement JWT authentication, right? Okay, so what Magnus said for anyone watching at home is you could implement this in Postgres 18 because of the flexibility and authentication methods, and 18 isn't released yet, we may remind you, but a plugin for checking JWTs is not implemented yet. I would add that this JWT technology is mostly is mostly meant for HTTP requests, right? So it adds a lot of traffic to your network stream, and I'm not sure that you want that between your application and your database. You want it to be as lightweight as possible.
All right. So first of all, free advertisement. I want to start from the end. So this is a super awesome book. I did technical review for this, and you know what? I know a thing or two about Postgres. In each and single chapter, I found things which I did not know. So I cannot recommend it more. When it will be published, I want to make sure all of my DBA team has it and use it. It's just super awesome. So use this discount. It's like great. Okay, that's number one. Number two, yeah, thank you. It was super interesting, and like I know the problem intimately, and it's very, very cool approach to solving it. And like I actually wanted to say about this, like you want to avoid this multiple backs and forth, so basically you answer this. Like one little comment, like I know you know, but for like public education. So when you do security defined function, which is, I also use them as a great way to give users exactly what they can do and not a centimeter more. But we also need to revoke execute from public because functions, so functions by default are executable by anybody. And normally you kind of limit them because users have limited access to underlying objects. But when they do security definer, if the first thing you would not do, revoke, execute from public, then anybody can become super user. So like what Jimmy showed, just security definer, revoke from public and grant only to the user who needs it.
Right.
Yeah. An ideal way would be just to make the applications use functions, which I succeeded twice in 40 plus years of my career, because then it's kind of easy. You actually can control it like inside the function, and you do not need to do this checks, and then you also reduce overhead this way, because then you can optimize it the best way.
Yeah.
But yes, this is the next best way.
I think we've reached a disconnect between developers and database developers or database administrators that we probably should not let developers include SQL statements in their code anymore, right? That is bad practice.
Yes.
So whenever you want to expose data from the database to your application users, probably the safest way is to define a function. And the function may return a table, right? You can define functions that return tables or sets of records. And they can use them exactly in the same way that they would select directly from the table. But nowadays, that SQL gets a bad rap, and people say, oh, it's obsolete, or it's an old language, and we're TypeScript developers, we don't need to care about that. And then they try to select something from a table and construct a horribly mangled query that takes 30 seconds to run with the next release, where the previous release only took 1 millisecond to run, and you try to figure out what happened in your database and why it broke, right? It's probably best, if not for security reasons, at least for performance reasons and reliability reasons, to expose data access through functions. There's a question in the back.
What's our question?
I just wanted to add on to what you said, and then I have a question. It would be great if developers actually learned SQL instead of relying on ORM abstractions. It would make everyone's life easier, even if you are writing functions to return data.
It would be great, but they are actively being told that this is the domain of the DBA. You shouldn't care about things like that. And then they go out and they get a job in the real world, and they are expected to write SQL queries.
Yeah.
And they inevitably do a bad job at it. You can read books, you can read blogs, you can look it up on Google or Stack Exchange, or Stack Overflow, but really there's no substitute for experience. So you should probably ask your DBA if you're a developer and you're not sure how to bring stuff or write stuff into the database, just fire an email or Slack message to your DBA to double check if that's kosher or not. And that eliminates 99.9% of disconnects and problems.
Don't be afraid.
Don't be afraid of the DBA, who is usually a middle-aged, bearded man who's almost always angry.
All right, now my question. Sorry.
Sometimes female angry person. This was a jab at the lack of diversity in our circles.
Which is fair.
Did you have another question?
I did. I actually had a question. So in the wild, in actual reality, when you're seeing these, where does the evaluation of the ACL take place in the query plan?
Sorry, your question was how long the evaluation takes?
Yeah, yes, because most people aren't trying to read the entire table. I imagine there are other indexes at play.
Yeah, the index helps a lot. So it takes like fractions of a millisecond for tens of millions of rows.
Great, cool.
So yeah, that's the job of the index, right? As someone pointed out earlier today, the job of an index is to pre-calculate the output of this function. So you store the output of the function that compares this to that, and you have it ready for all those rows, instead of running it for every single row.
Okay, another question?
Hi, I was looking at the use of the UUIDs, and it jogged my memory about UUID 4 versus 7 and the different kind of index impacts. Is there any benefit to using time-sorted UUIDs if, like, let's say we have an example of some other database user writing lots of rows, and
So
then you
the
have something
question-
reading?
Sorry, did you have anything?
Yeah, which, like, is there any benefit to using UUID v7 for this? And if so, like, do we need to change what kind of indexers we're using to make this work better?
Right, so the question is, well, first of all, UUID 7 isn't available in Postgres yet, right? So this is a feature that's getting added in Postgres 18 that's coming out later this year, fingers crossed. So is there any benefit to using a time-based UUID like UUID 7 versus a truly random UUID, a fully random UUID like UUID version 4? Well, the answer is if you want to do something with your identifiers, like sort them by time, then yes. It would give you a way to encode secret knowledge into the UUID, like the creation date, for example, of that user, or the creation date and timestamp of that role. And it would let you sort the UUIDs by time order, let's say, or numerical order. Is that something you would need to do? Probably not, because you would already have a creation date for your customers or tenants anyway in that corresponding table. So it wouldn't be bad, it wouldn't add significant functionality in my opinion either.
Okay. Everybody, thank you very much. We give a nice round of applause to Jimmy here. Appreciate you coming out and talking. Thank you.
you.